Okay. So I want to know the distance from A to B. But instead of just the straight line distance, I want to know, like, if we put a piece of yarn and traced it over the curve from A to B, how long would that yarn actually be? Okay, that's what we're looking for when we're talking about arc length. Okay, so let's talk about the distance between 2 points that are really close together, right? So like P sub I and that point right there. So I'm going to call it P sub I minus 1 and P sub I. We're going to find the distance between those 2 points, okay? How do we find distance? Oh. Okay. He should be sitting like kind of with all the secretaries.
X minus x squared plus y minus y squared.
Mm-hmm. Okay. Now, what we can do is we can call this the change in x squared, right? It's like change in x plus the change in y squared, right? Okay. Now, let's not worry about those little I symbols, okay? Take those out now. I'm going to do a little trick, a little math magic, if you will. I'm going to multiply this by delta x over delta x squared. Okay? That is legal because essentially we are multiplying by 1. Does not change the value. Okay? Now, what I'm going to do is I'm going to take this numerator and I'm going to actually take the square root of delta x squared. What is that?
Delta x.
Delta x. And then I'm going to keep delta x squared from the denominator inside. So when I take delta x squared times this delta over this delta x squared, we get 1 plus delta y squared over delta x squared. See where this is going? Maybe, maybe not. What are you doing?
I don't always have time to
Okay, so you can take a picture.
go along with you, and I don't want it to get lost.
Although honestly, this is just a proof. So.
Okay. So what I'm going to do is I'm just going to rewrite this as delta y over delta x squared. Okay. So now this represents the distance between 2 points that are really close together. What are we going to do with this now? Okay. Well, we're going to take this as x approaches 0, but we're also going to add up a bunch of these little pieces, right?
So the summation.
So we're going to sum all of these together. Well, delta y over delta x is just the same thing as the derivative, right? So we're going to sum all of these together, and if we take the limit as this goes to infinity, we get, okay, so here's our integral. Arc length, integral from a to b of square root of 1 plus f prime squared. Okay, so if I ask you, what? If I asked you to find the arc length, the first thing that you're going to need to do is find the derivative, so you can plug that derivative into this formula. Do you find them okay?
Yeah.
Okay, thank you. All right, I'm gonna do a fun one. Ready? We're going to find the arc length of y equals x cubed over 6 plus 1 over 2x on the interval 1/2 to 2. So, 1/2. Finding that little piece right there. Okay? I told you the first thing that we need to find is what? The derivative. What is the derivative of x cubed over 6?
X squared over 2.
And what's the derivative of 1 over 2x? Squared.
Maybe 1 over x squared.
Do you agree with Josh? Power rule, drop the -1, decrease it by 1. So minus 1 over 2 x squared. All right. So now for our arc length, we have the integral, I don't know what that means, from 1/2 to 2 of the square root of 1 plus x squared over 2 minus 1 over 2x squared dx. Squared. Sorry. We're going to do it by hand. It actually works out very nicely, okay, if you can trust me on this one. All right, let's talk about how we're going to do this one by hand. This is not the last time you'll see a problem like this. First thing we would need to do is what?
Multiply.
Multiply everything out. So remember, if we have a binomial squared, we get a squared. Okay, in this case, minus 2 times a times b, right? These two multiply together twice. So what is a times b?
1 over 4.
1 over 4, right? The x squareds cancel. We have 1 over 4. But we have it twice. 1/2. Plus, what is our b squared? Excellent. So now what we can do is combine our like terms. So we have, and I'm going to keep it in a certain order, so don't get thrown off here. X to the 4th over 4, 1 minus 1/2 is a positive 1/2 plus 1 over 4x to the 4th. Okay, just tell me this isn't getting us anywhere. It actually is. I want you to look at that pattern that we have underneath the radical, and I want you to tell me if that looks any familiar. To anything else up there? The pattern underneath the radical, do you see that? Or something similar to it anywhere else up there? Look at those two. terms are the same except okay, right? X to the fourth over 4. This one's minus 1/2. This is plus 1/2. This one is plus 1 over 4x to the fourth. Do you see that, how they're similar?
Yeah.
Where did this come from? Right, when we squared the derivative. Okay, so what could that factor to? If this multiplied out gave us this, what will this one factor to? Yes. Okay. This binomial squared gave us this trinomial. Well, this trinomial is the same except this is a positive instead of a negative. So this is going to factor to this perfect square binomial. That won't always happen, but with certain problems it will. Ones that you would need to do by hand, this would be something that would need to happen, right? To get rid of that square root, okay? Because we can't really take the integral right here with this square root, okay? We need it to go away. Because right now we don't have anything to do u substitution with or anything like that. So, yes. So now that the square and square root cancel, we now have a very nice power rule integral. Okay, now we can actually integrate it. Okay, the only time we can integrate when we have a function inside of a square root is if we were going to use u substitution and there that du existed somewhere, right? If we were going to let u equal this, we would need a x cubed somewhere plus an 1 over x to the fifth somewhere. Like it'd have to be like the perfect math, right? But now we have a nice power rule. Now we can say x cubed over 6, right? Yep. Minus 1 over x to the first, right? I'm thinking about that right?
1 over 2x.
I forgot the 2, right? Evaluated from 1/2 to 1. Yep, 1/2 to 2.
So basically just took the equation we started with, x cubed over 6 plus 1 over 2x, and just took it from 1/2 to 2, or 1/2 to 2.
No, we started with plus. We ended with minus.
Oh, okay.
Yeah. You guys go through all that work. Okay. But I guess my warning to you is that this pattern right here will appear in a few problems, so I want you to be able to recognize it. Okay. I know that you can evaluate an integral. Okay. I will tell you that the answer is 33/16, but we're not going to go through that computation right now. Okay. Now, what I'd like you to do is get out your calculators, and we're going to talk about the straight line, like the straight distance between these 2 points. So over here we found the arc length. Now I want the distance between those 2 points using the distance formula. Okay. If we plug 1/2 into our equation, our y value is 49/48. And if we plug in 2 to our equation, our y value is 19/12. So I'd like you to take those 2 points and find me the distance between them with the distance formula. did you get, Josh? Just in the-
I'm not sure of it, but it's like 1.602.
Yeah.
Oh,
Approximate 33/16 for me.
sure. Wait, approximate fraction?
Yeah.
Oh, good. I got 4795187/29932469.
What? 33? No. Approximate this one.
Oh, 2.0625.
Okay, do you agree with Josh with the 1.602? So you're getting? Yes. Okay. Does it seem reasonable that our straight line distance is smaller than our arc length?
Yes.
Yes.
Yeah? Our curve looks like this, right? So our straight line distance should be shorter, right? That should always happen. Okay. Let's do another one. This is a nice one. Okay, so we have the natural log of the cosine from 0 to pi over 4. First thing you need to do before we find arc length is find the derivative. Okay, so derivative of the natural log.
Your tangent next.
Step ahead. Okay. If you're talking about the tangent, or now that word's in my brain. Okay, if you're talking about the natural log, 1 over what's inside times the derivative of what's inside is negative sine of x. So negative tangent x is our derivative. Arc length is the integral from 0 to pi over 4, square root of 1 plus our derivative squared. Can't take the integral right now. Is there something we can do with 1 plus tangent squared?
Run like, sorry.
Opposite equals something. Isn't there some rule?
Yeah, there's
There's an identity.
It was like 1 plus sine equals.
Sine squared plus cosine squared equals 1. Okay. So what is 1 plus tangent squared equal?
squared.
Yes. Right? Sine squared plus cosine squared equals 1. So if we divide everything by cosine squared, tangent squared plus 1 equals secant squared.
I don't know all these rules anymore.
If you need to reference them, they are in the front of your book. Okay, really, if you can remember sine squared plus cosine squared equals 1, you can figure out by dividing everything by cosine squared that 1 plus tangent squared is secant squared, or you can divide everything by sine squared and get 1 plus cotangent squared is cosecant squared. Okay, but it would be a good idea to know the Pythagorean identities. Okay, so this is helpful. We now have secant x dx. Okay, where'd your calculator go? I thought you put it on there. You put it away?
I did.
Okay. And we're recording these for you. Hi, Sean. Okay, now, we've gotten to a point where we have to take the integral of secant of x. This is one that I would not expect you to remember off the top of your head for like a quiz or a test. But if you get out your book, you can look up, and it's either the front or the back. I can't remember which one. Does anyone have their book? Scott has his book. All the integral rules. What is the antiderivative of secant x?
Secant of x plus tangent of x plus c.
There it is. Okay, so that's something you need to look up. Right, because we can take the antiderivative of secant squared. Secant, not so much. And then we need to evaluate it from 0 to pi over 4. So we have the natural log of what is the secant of pi over 4?
It's square root of 2 over 2.
Square root of 2, because it's 1 over radical 2 over 2. Okay, plus the tangent of pi over 4? Minus the natural log of what's the secant of 0?
It's undefined, is it?
It's 1. Reciprocal cosine.
Shouldn't those be absolute divised instead of?
Well, but since our numbers are going to be positive, it's okay. Plus, what's the tangent of 0? 0. And what's the natural log of 1? Alright, so let's talk about some arc lengths. I mean, that's what we just talked about. Let's talk about some surface area. Okay? So surface area, in order to get anything with surface area, we're basically going to take an arc length and rotate it around an axis. Okay? Either the x-axis or the y-axis. Okay? So if you look at this little band here, if I take a little chunk and I rotate it around, and I'm talking about the surface area, well, we have kind of, its distance around is the circumference, right, 2 pi r, and then it has thickness of that ds is what I've labeled it as, okay? Well, if we add all of those up, right, we'll add all of them up using an integral, okay? Well, right now, I have just 2 pi y, where y is our radius. Thank you. Now, let's relate this to arc lengths. We know how to find the length of an entire function, right? And then if we twist that around an axis, keeping this same 2 pi r concept, we have 2 pi r times the length of our entire curve. This is us rotating around the x-axis. If we wanted to rotate around the y-axis, we would have to switch all of our variables. Okay. Yes. Good point. You're not going to write y in your integral and have x's and y's in the same integral. Whatever y is, you're going to replace it with that function. Or are we all done writing it down? Really? Yeah, okay. So we're going to take y equals radical x and rotate it about the x-axis. Okay, so just like with arc length, we are still going to need the derivative for our integral. So what is dy dx? 1/2 radical x. Agree? All right, here we go. 2 pi y. All right, are we going to write y? What are we going to write instead of y?
Wait, that would be inside the, wait, from what to what? What are our inputs?
We'll get there. Let's set this up first, okay? So I just put the 2 pi on the outside of the integral. Is that okay?
Yeah.
Okay, here's our y times radical, basically arc length, right? 1 plus 1/2 radical x squared dx. Okay? So we're just going to do what this picture is showing us. So our limits of integration are going to be 0 to 9. Okay? So we're rotating around the x-axis. Not only could we find the volume of this figure, but now we're finding the surface area. Okay? Now, this is one we can do by hand. To save some room, I'm going to go ahead and rewrite this. What can we rewrite this as?
1/4x.
1/4x. Okay. Now, what can we do with our radicals? When we multiply radicals, we multiply what's underneath. Okay. So this becomes 2 pi integral 0 to 9 of radical x plus 1/4. X times 1 is x. X times 1/4x is 1/4. Right?
But you have to square it when you put it into a radical. Inside of the radical.
Well, they're both under the radical.
Well, that's what I'm saying. It's like, assuming x is like some sort of constant or just some number, or if you wanted to put it inside the radical, you would multiply it by, you just have to square it. And then distribute it.
Like if that were x instead of radical x, is that what you mean?
Yeah.
Okay. Now, can we integrate this? Well, to look nicer. Okay. So we can leave the 2 pi on the outside. We can make this x plus 1/4 to the 3/2 times 2/3 and evaluate it from 0 to 9. I'm not going to plug in the limits of integration. I would like you to begin your homework before we leave here. So is that a step that I can skip and you guys can be okay?
Yeah.
Yeah. I can trust that you're capable of plugging in B and you're plugging in A. Okay. However, hold on. Before I give you your homework, I would like you to set this up for me. Bailey, you're setting this problem up. What's that mean?
I don't.
Okay. This is not one I'd have you do by hand, FYI, if you were panicking from this. Made a mistake, we'll fix it. Alrighty. Okay, here is Sammy's integral. Any questions for Sammy?
F prime x in parentheses and squared.
Yes. So she needs this.
I think so.
Okay, so I think Sammy agrees with you as well. Yes.
And is that a 2 right there?
Yeah, that is a 2. It takes some time to get used to. All right, as long as we know that this is a 2, is everyone okay with that?
I would not make you do this one by hand.
So I've separated your homework out into by hand, by calculator. Okay, make sure you can do the ones by hand. Really, I am concerned with the setup of these problems. Okay, however, you are going to have to do some of them by hand, not only on Friday's quiz, but your chapter test. Okay. So make sure you practice. That's a great question. So next week we're going to do a lab with work where you're going to actually calculate the work it takes you to drink water from a straw. It's going to be pretty fun. And then we're going to talk about centroids. So we have section 6. and then we'll review for our test. And unfortunately, our test is gonna have to fall after our 4-day weekend, so that just means you have a lot of time to study.
Or a lot of time to forget.
When's our 4-day weekend?
Yeah, what is the
Next weekend, like not this weekend, but the next weekend. Next week is conferences.
So, Friday, Saturday, Sunday.
Oh, God.
Yes.